So again, what's our objectives? Well, we want to again get a proper shape concrete object when we're done. We want to have good quality. We want to make sure things are safe. We want to make sure that we do things economically. So how does formwork affect concrete quality? Well, if the forms have to be rigid, otherwise we're going to get bowing or we're going to get bulges. They have to be stable and strong enough so that you can keep large members in alignment. Again, no bowing, no bending, bulging. They have to be substantial enough so that you can reuse them. Again, that's an important part of what we do with especially wood forms, but again, metal forms too. They have to be substantial so they don't get bent and they don't break. And you have to make sure that formwork stays in place long enough until the concrete's strong enough to maintain its own weight. Or when if you don't, you try to take them down too soon, you're going to damage your structure. Could collapse, could fail. So one of the rushes you always have in formwork is how quick can you strip the forms and move them on to the next part of the project. And the thing is, you have to make sure you have strength in the concrete members that you've just made. That's one of the causes of formwork failure. So what are other causes? Well, again, you can have a failure right when you're placing the concrete because of the impacts, because of the vibrations, the crews moving around, the loads that aren't equally applied to the whole structure. There may be some unexpected events, something hits the forms, or again something is dropped on them. Improper stripping and removal of the shores, inadequate bracing, and bracing may just seem like an afterthought, but it's there for a purpose. Again, the vibrating when you're doing concrete work, too much vibrating, and again, too much vibrating isn't good for the concrete in the first place. Over vibrating can cause the forms to come apart. If you don't have stable soil that you're working on, you have to make sure that the base is good enough. And you don't control the concrete. You don't just have control of how people are placing it into your forms. And again, also a lack of attention to the formwork details themselves. Again, we kind of beat safety to death, but it's important. Formwork, though, has to be strong enough to carry the full load from the fresh concrete, construction traffic, equipment. You have to use good quality, durable materials. Again, we've been talking a little bit about different types of wood, timber. Remember all the timber defects we looked at? Well, that's one of the things that can be a problem. You want to make sure that you meet OSHA requirements. Remember, we already talked about ACI and building code, but OSHA also has requirements as far as the way you go about making sure your forms are safe. So you'll need to know about OSHA. If there is a failure, OSHA is the overall enforcing agency that's going to be coming down to make a determination as to what happened if you met all of the different requirements, not just OSHA's, but all the other requirements that are out there too. When you're planning for formwork, you need to do it back at the time, especially if you're a contractor on the contractor side of the table. At the time of making a bids, remember we already talked about that a bit. When you're making bids and you're looking at estimated time to do work, one of the big impacts on the time is how quickly you can reuse forms on a site. Right? How quickly you can strip them, move them on. The option to having one set of forms and moving them around to 4 different places is building 4 separate sets of forms. And that's one of the trade-offs you're going to be looking at. What's cheaper? building 4 forms at the same time, using them once, building 1 form and using it 4 times, stripping and waiting each time between, or building 2 forms and doing the same thing. You have to consider capacity of equipment to handle your equipment. Remember, if you're going to build 4 forms all at the same time, you're going to need equipment to be able to do that. So again, you see the cost goes up because you're going to be either having to buy equipment or rent that much more equipment. You need to talk about how you're going to handle construction joints. You're going to look at, do you build the forms on site with a crew of carpenters, build them in a warehouse and haul them out to the site and just assemble them, or you're going to have some ready-made forms that you're just going to bolt together again out on the site. And you need to know about weather, and it affects everything we do in construction. So I'll just say, when you're doing your estimates, you need to factor in weather time, how weather stops, and remember one of the most important things, if for example, rains, you usually can't go right back to work on a construction site immediately after it stops raining, especially if you're working on bare ground or on the grade, because the grade needs time to dry out for the moisture to go away so that you can work. You can work in mud, but you don't get good product, and that's one of those cases where you lose stability in the base that you're working on that we mentioned a couple minutes ago. So rain can affect you, cold can affect you the same way. Cold in particular, remember, slows down the curing of the concrete. And what that really means, especially when the temperature gets below 50 degrees, is that concrete doesn't cure really rapidly at that point. It may take twice or 3 times as long, say 3 or 4 days as opposed to 1 or 2 days when it's warmer, for the concrete to get proper strength. So if you're going to be working in cold weather, you have to account for that. And again, you may insulate things, but that doesn't necessarily mean that it's going to get the temperature above 50 degrees. The insulation will probably just keep the concrete from getting below 32 degrees or freezing. Again, in either case, whether it's 50 or 32, you're not going to get any additional strength. So that can slow your project down. So you see how all those things work together to increase your bid cost if you don't account for them properly. How can you, again, deal with costs and actually even reduce costs, especially when you're putting a bid together? Plan for maximum reuse. We talked about that. Use them as many times as you can. It means you have to protect them. You have to use good material. You have to use the proper procedures to assemble them and disassemble them, but it's possible. Use economic construction procedures. If you can, build them in the shop, bring them out. It's more efficient. You get better accuracy, and you can build the forms even when it's raining and bring them out and put them up. You can make a shop area on the site too. It's nice if it can be enclosed or a place where the elements won't bother you. Protect your tools, protect the timber that you're using, the lumber. You can, for a small job, you can build the forms on the site economically. Again, we talked prefab forms, and we talked about renting them. All those are options depending on the project and where you are and availability. Remember, availability of forms is also important, especially if you want to rent them in the middle of a busy construction season. It's a common type. They may not have them for you. Setting and stripping is a way to be able to save some money, especially if you use clamps and wedge pins to hold things together. It just makes the operation quicker as opposed to nailing together, and even with the double-headed nails, it takes a while to start pulling nails out. And you can put handles on them to make them easier to move around, or the pieces. There are a lot of things. Again, think about the people who are working on the site. Think about the tools that you need. And again, for a lot of smaller sites, you're going to have a small lift. Lots of hand tools, hammers, saws, ladders, scaffolding. Several grades of carpenter, probably a carpenter and a helper carpenter or two. All of those things together are going to, first of all, make the cost, but by using them effectively, they'll help bring the cost down. If you've got big forms, again, remember we've talked about cranes and hoists, big ones and little ones. You want to be able to use an economical crane. In other words, if it may be that you're going to build a form in several pieces so that a smaller crane can be used. So what's the advantage? Small cranes cost an awful lot less, and they save you money, and they can get around a site better. They don't need as much room. There's lots of reasons to use a small crane. Bar setting. Again, one way to put your bar or your wire mesh in place is to bring it on the site pieces and assemble it there. Again, assembly on a site in a grade is always problematic. Building your cages, your reinforcing rod cages, insofar as it's possible in the shop, and then bring them out on the site. It's factory built. You have a lot more accuracy. Things stay cleaner. You haul them to the site. Use a crane. Again, if you got the proper size crane, it can move forms and also lift up your cages. But you don't want to have a special crane just to lift a cage up necessarily. Again, it's economics. And you can set the cage in place. So again, there's a lot of different ways. Factory costs a little more on the face of it, but the quality is superior, and you have a lot less chance of having to redo a piece of work, which is the ultimate in expense. Again, you have to consider when you're actually putting the concrete into the forms, how much you're putting in, placement rates, and as you've seen already from the program, if not, go back and look at it when you're done. How quickly you place the concrete directly affects the size of the forms, the size of the members, the timbers that you're using. So we'll talk a little bit more about that in a few minutes. Then we've been looking at forms, and I would again talk about terminology. Sheathing, remember that can be plywood or it can be built up from individual members. You got the studs, the vertical members. There's a stud. You got wales, which is the horizontal members that go behind the studs and hold in place. You have a plate at the bottom that the studs sit on, and your footing, a concrete footing. You have a key. Okay, and you have, again, ties that go from wale to wale through the sheathing to hold and resist the outward pressure. Again, on the inside, you're going to have some type of separator also to get this dimension properly, right? Okay. Plywood sheathing is more common than boards nowadays. It's just easier to handle. And I think you can get better quality overall if you buy a good quality plywood. Again, for wall form, we were looking at one view, and you see the wales and the studs. We're going to talk about spacing. As you can see, the spacing that we're going to be worried about, the spacing between the studs here, 1 foot center to center, you see. That'll vary, and you'll see the spacing between the wales. Clearly, we haven't really talked about it, but obviously the wider apart you can space the studs and the wales, the less material you need, right? The less 2x4s and 2x6s, and the less timber you need. So one of the objectives is to vary the size of the studs and the wales and the sheathing by size so that you can, again, get the proper support, but also minimize the amount of lumber altogether that you're going to be using. That's kind of the point of the exercise. You want to have a safe support when you're done, a safe form, but you want to use the right amount of timber. We've been talking about ties. And again, there's different types of ties that you talk about. Then the tie goes from the back of the wales on each side and keeps the form from spreading in here when you fill this area up with concrete, right? So, and we were talking that there's different types of ties depending on what kind of work you're doing. And again, we were talking about the taper wedges, and you see those taper wedges on these here to help make assembly obviously quicker than if you have a screw-on member to hold the tie in place. Again, that wale, or that works against the wale right back here. You see, it'll be this spot will be here. You can see that again, you can have wales that have sleeves on them that, again, they can be pulled out easier. The sleeve is going to stay in the wall or in the component you're building, and then you're going to have to fill it somehow. Okay, you're going to have to treat it. When you look at concrete walls, if you ever looked at a concrete wall in your basement, for example, you see the little holes, or where they had filled holes. What are all these holes for? It's for the ties. And so you can't leave the holes because it goes through the wall, and water or whatever will come in. So you need to grout those shut when you're all done. So again, grouting takes time, doesn't it? The more you can spread the wall, the fewer members, the fewer ties you need. Again, the less holes you have to fill and treat when you're all done. Again, there's a wide variety of ties that you can get and use for different projects. What's the best way to figure out what you need? Well, I talk to the people who make the ties. They're going to tell you which ties you need for any particular job. We've been looking at wood. I'm going to spend a lot of time at this at all. We know that a 2x4 isn't a 2x4. And we'll leave it at that. But we also know that we're interested in the moisture content, aren't we? Wood that is too dry sucks the water out of the concrete, will cause problems. So you're looking for a green timber that has moisture content in a reasonable range, so that it won't absorb moisture from the concrete. Again, if you have a piece of dry timber and it absorbs moisture, it starts warping too. So it'll bend or twist. Now, you may have it nailed in place. What happens? The forces that are trying to bend and twist it are going to work to try to tear your forms apart, to pull the nails out of the formwork. Okay, and again, eventually when you do take that form apart, that wood is going to twist on you, and it's going to warp and bend, and you may not be able to use it. If you planned on using forms 4 times before you dispose of the wood, you may not be able to do that. If the moisture content isn't right, the wood warps, you may not be able to use that wood for four turns. There are different types of engineered wood products. Plywood is the main one. Some of the things we're going to do with it. All right, so you use plywood for a lot of different things on site, especially if you're building a wood structure, roofs and floors, sheathing, shear walls, gusset plates to hold 2x4 smaller timbers together, and of course concrete formwork, what we're talking about. One of the things you see, and especially if you go back and look at the program that I've given you, you're gonna talk about which direction the plywood is facing. And you'll see there's a weak way and a strong way. And what's the difference? Well, let's look at the weak way. You'll notice they're alternating layers. And plywood is made out of wood veneer. It's a thin layer of wood that is peeled off a log. And you'll see the grain here, right? And in this case, when you're laying the wood on the joists, the plywood, if the grains are in the same direction as those joints parallel to it, then that's the predominant direction for that plywood. That piece on the top and piece on the bottom are going to be like that. Again, when you load onto that plywood, you can see here, if you apply a load down on that wood, you see the grain being supported in the same directions as the joist. It's the weak direction, right? Down here, you'll see the grain crosses over the joists, right? So the strength in this wood is, if you apply down on that line, you see that the grain resists the forces, and that's the strong way. Why would you do it one way or the other? Well, it depends on, in part, how the plywood is made that you get. Okay, so you want to be able to, the size, remember plywood comes in 4x8 sheets, so you're going to want to know or specify the direction of the grain on your plywood, or know which way it is, so that you can make a determination when you're calculating your designs, the direction. Okay, so weak way and strong way. And this particular chart does show you also what happens in terms of bearing stresses or crushing. You can crush the grain of the wood. And again, it goes back to the previous chart and gives you some criteria in terms of where to apply loads and how they can be applied, and with respect to the members being stressed. Okay.